Okay. Good afternoon, students. I am Karthik. Assistant Professor in Konar College of Engineering Technology. I handled a subject for ATK Machines 1. So, what topic we are going to discuss here is today we are going to discuss about the electromechanical energy conversions and basic concept of in rotating machines. So, what you are going to discuss here? So, we discuss only for DC generator and DC motor and transformer. Generally, in DC machine can be classified into there are two types. One is for DC generator, another is for DC motor. We know that generator is nothing but to use to convert in terms of mechanical energy to electrical energy. Motor is nothing but we are going to convert in terms of mechanical energy to electrical energy one. This is called as energy conversion principle. Energy conversion principle. Okay. So there are having the so many electromechanic energy conversion devices used here. What are devices used for conversion process? One is for through the microphone, loudspeaker, strain gauge, thermocouples. That is used for only for low energy signal. Low energy signal. And also another device used here that is called as continuous energy conversions. Is nothing but rotational motion. Okay, there are two motion. One is for linear motion, another is for rotational motion. For linear motion, for example, for hydraulic machine. For rotational motion, for example, for generator and motor. This is having the block diagram of electromechanical energy conversion devices with respect to generating devices with respect to motor devices. So both the devices have the energy conversion process. For generating devices, input also mechanical energy, output also electrical energy. And also motoring devices, input also electrical energy, output also mechanical energy. This is called as electromechanical energy conversion process. Okay. So how to balance the energy? So whenever we are going to convert in terms of electrical energy to mechanical energy or convert mechanical energy to electrical energy. Okay. At this time, we balance the energy. We balance the energy. So that parameter we're going to calculate. Okay. Suppose we are going to convert in terms of electrical energy to mechanical energy or mechanical to electrical energy, so definitely losses will be formed. That loss is called as energy losses. Energy losses. Okay. So there are the two types of input energy. One is for transformed energy, another is for energy losses, another is for stored energy. For stored energy. Okay. See the diagram here. Yeah. See the diagram here. Here, input also electric energy, output also mechanical energy. So by using the motor, we are going to convert in terms of electric energy to mechanical energy. At the same, some of the energy stored. Okay, that is called as changing the energy stored in the magnetic field. At the same time, losses will be formed. Okay, loss will be formed. That is called as total energy losses. For generating action, we are going to convert in terms of mechanical energy to electrical energy. Okay, mechanical energy to electrical energy. Okay, so at the time also some of the energy will be stored and also losses will be dissipated. That is called as total energy losses. This is called as energy stored in terms of magnetic field. This is called as energy balance equation. Energy balance equations. Okay. So whenever we go and convert in terms of electrical energy to mechanical energy to electrical energy, Energy store in terms of positive, it may be negative. Okay. Suppose if it is energy stored in the magnetic field or electric field increases, okay, this is called as positive. Okay. Suppose energy stored in the in terms of electric field or magnetic field decreases, it may be a negative. It may be a negative. It may be a negative. So how to write the in terms of energy balance equation? Energy balance equation in terms of mathematical model. In terms of mathematical model here. So how in terms of mathematical model, so model is, so we're going to convert, so in terms of, this is called as electric energy, so that can be represented by differential electric energy is called as dw. Dw is nothing but differential mechanical energy, nothing but energy stored in the in terms of magnetic field, that can be written as dw. So that means loss will be formed, and okay, that loss is equal to dw losses. See, in terms of whenever going to convert in terms of electromechanical energy, we write the energy balance equation here. dW equal to dW plus dW plus dW losses. Okay. So this is called as electromechanical energy conversion devices. Okay. So which law used for to use for in for generating action for motor reaction? By using the Paredes law. By using the Paredes law. So whenever current getting under space and magnetic field, they cut the magnetic field, EMF will be induced. So due to the EMF, due to the EMF, DC machine will be operated. DC machine will operate. So when the EMF induced in condition directly proportional to the rate of change of flux linkage or flux in the number of turns. Flux in the number of turns. Okay. So according to Lenz law, EMF induced in the conductor always opposite produces. That is called as statically induced EMF. Statically induced EMF. Statically induced EMF. Okay. So according to Lenz law, so when EMF will be induced, there are two types of induced EMF. One is for static induced EMF, and is for dynamically induced EMF. Okay. So here, so when the EMF induced, okay, according to Biot law, we can write it for E equal to BLV sin theta into V. Here, when the theta equal to 90 degree, so induced EMF equal to B into L into V. B is nothing but maximum flux density, L is nothing but length of the coil, V is nothing but velocity of the conductor. Velocity of the conductor. The conductor. Okay. So next we are going to Lorentz force. So that Lorentz force can be written by using primary right hand rule. Primary right hand rule. That force is equal to F equal to B into I into L. I is the current. L is the length of the conductor. Length of the conductor. So this law is from the this law used for electromechanical energy conversion process. Energy conversion process. So whenever we are going to convert, there are convert in terms of electric energy to mechanical energy or mechanical energy to electric energy. So there are in the two system used here. One is for electric system, one is for mechanical system. Okay. So we know that mechanic for generator something where input also mechanical, output also electrical. For suppose for motor something but input also electric, output also mechanical energy. So whenever we're going in terms of either electric energy to mechanic energy or mechanical to electric energy, losses will be formed. Loss will be formed. Okay, loss will be formed here. Okay, so that can be represented by in terms of energy flow diagram. Energy flow diagram here. Energy flow diagram here. See the diagram here. So what we understand. Okay, is here input also mechanical energy, output also electrical energy. Okay, this is called as mechanical losses. That mechanical losses in terms of friction loss or iron loss here. That loss can be represented in terms of torque, in terms of force. So in, that can be represented by integral of T torque into angular plus into dt. In terms of force, in terms of velocity, that can be represented here. Okay. So this is coupling. This is we can use a medium here. So this can the losses. This can the losses. Here output also electrical output that can be represented by power equal to V into I. V into I. So that can be represented by integral of V into I into dt. So what are the electrical losses? Generally there are the two losses. One is for copper loss, one is for iron loss. So iron loss. Okay. This is for energy flow diagram for generator. For generator. Next one is for motor. So for motor. So here output also mechanical output, input also electrical input. So that LT input can be in terms of power in terms of input equal to V into I, and also output also that can be represented in terms of integral of f dash v into dt, integral of t dash into w into dt1, d into dt1. So there are kind of two types of uses system here. One is for mm, one is for single exit system, other is for multiple exit system. Okay. So each and every magistrate we can use a different type of coil used here. Okay. So given input also different input. So according to the number of input, number of excitation, we can use a system that are having a classified. There are two types of system. One is for single excited system. So single exit system used for system. For example, electromagnetic relay and reluctance motor and hesic motor here. See the diagram here. See the diagram here. Here input also single electrical source. This is also LTI system. So when the supply voltage given to that particular coil, in around the coil flux will be produced. So based on this one, load will be operated. Load will be operated. This is called a single excited system. For multiple exit system, for example, so two excitation coil be used here, two input source will be used here. This is called as double excited system. So what are example for multiple exit system or double exit system? We can use in industry we can use a synchronous motor, alternator, loudspeaker. This are for example for uh, multiple exit system. For other case, for AC motor we can use a stator and rotor here. Stator is a stationary part, rotor is rotating part. Okay. So for the case, input supply is given for separately. For with respect to stator, with respect to rotor, with respect to rotor here. Okay. So when the supply voltage give this stator here, this also produces a rotating flux. Okay. And also this is also rotor also produces a flux. Okay. When the two plugs coincide to each other, one force will be formed. Due to the force, this rotor will be rotor will be rotor will be rotor will be rotate here. It will be rotate here. So now we are going to discuss about the multiple excited system. Multiple excited system. Multiple excited system. Okay. For whenever we're going to convert in terms of electrical energy to mechanical energy or mechanical to electrical energy. Okay. So from this one, okay, we consider for alternator for synchronous motor. This is example of multiple magnetic system here. Okay. So for mostly for industry application, all are having the working for multiple excited magnetic system here. For understanding purpose, this is going to crosses view of the multiple excited system for AC machine there. AC machine sir. So V1 is the supply voltage. I1 is the input current. This is status as a stationary part. V2 is the supply voltage for rotor. I2 is the input current. So torque is the force. This is theta is the angular displacement with respect to stator and rotor. So when the supply voltage into this coil here, okay, lambda one is nothing but flux linkage of the coil lambda. So in terms of inductance, lambda equal to L divided by I. L divided by I. By I. So when the input current is given to the coil here, this coil produces the flux in around the core. So at the same time, input supply voltage into the coil rotors area. So this is also produces a flux. This is also produces a flux. So due to the flux, one force will be formed. So due to the force, this rotor will be rotate. It will be rotate. So for the case, what we are going to find out, how much amount of force will be needed to rotate that particular machine. That parameter we will calculate, and also we know that the force movement is called as torque. Force movement is called as torque. The torque parameter also we are going to find out. We're going to find out. So we know already I told that I want nothing but current due to the source one. I2 is nothing but current due to the source two. Lambda also flux linkage of the coil with respect to current I1. Lambda 2 is nothing but flux linkage of the coil with respect to I2 here. Theta is angular displacement of the rotor. T is nothing but torque developed of the system. Here we can use the three independent variable. So one is for flux linkage of the coil lambda 1, lambda 2, and one is for angular displacement theta. Angular displacement theta. Angular displacement also theta 1. Displacement also theta here. So and also I1 and I2. I1 and I2, comma theta 1. Okay. So we know that what's the formula torque. Okay. Suppose we consider current as a variable one. So mean that I1, comma I2, comma This is a variable one that can be in terms of torque formula equal to in terms of field energy equal to minus dou W F divided by dou theta lambda 1 comma lambda 2 comma theta here here theta here. So we know the in field energy we can write for field energy equal to, so there are the two independent variable. In terms of field energy we can write the formula equal to W F in 0 to lambda 1 I1 into d lambda 1 plus I2 into d lambda 2. So we know the flux energy equal to lambda equal to L divided by I. So therefore inductance equal to L equal to lambda into I1. So in multiple exercises we can use a two coil here. One is for this put source one, okay, that corresponds plus in equal to lambda 1. So another coil for plus in coil this put rotor side, that coil equal to L2. Okay, L2. So this L1 equal to self induction of the stator coil equal to L11. L22 is nothing but self induction of the rotor. L12 is nothing but mutual induction between the stator and the rotor, or L21. So we know the form of flux energy equal to L divided by I. L divided by so we know formula equal to L equal to lambda divided by I. L equal to lambda divided by I. Therefore, lambda equal to L into I. So according to that one, we are writing for lambda equal to with respect to coil 1, with respect to coil 2, with respect to current I1, with respect to current I2, that committance for L11 into I1. So L12 is nothing but mutual inductance between the stator and rotor, that corresponding current equal to I2. Thus put the flex linkage of the coil lambda 2 equal to L12 into I1 plus L22 into I2 there. L22 into I2 there. So from this equation, we write by multiply with lambda 1 2 and lambda 1 in both the equation. In first equation, we multiply with L12. So therefore, we get for L12 into lambda 1, L11 into L12 into I1 plus L12 square into I2. Similarly, for another equation, multiply with L11 both the side. So we get the answer here. L11 into lambda 2, L11 into L12 into I1 plus L11 into L22 into I2 there. So it is for equation number 1 and equation number 2. So subtract this one, 1 minus 2. 1 minus 2. So here L12 into lambda 1 minus L11 into lambda 2 equal to, so all this one, these two will be cancelled. So we get the answer equal to L12 square into I2 minus L12 square into I2 minus L11 L22 into I2 there. So from this take the common for I21. So we get the solution equal to I2 is a common one, take the outside one. So L12 square minus L11 L22 here. So from this one we get for I2 equal to so I2 equal to, you bring the term for left hand side, we get answer equal to L12 divided by L12 square minus L11 into L22 into lambda 1. Here minus L11 divided by L12 square minus L11 into L22 here. Similarly find out for I1 also. So here, so that commitments for that commitments for beta 1 is nothing but beta 1 2 here. That commitments for beta 2 here. So finally we write for I2 equal to beta 1 2 into lambda 1 plus beta 2 2 into lambda 2 here. Beta 2 2 into lambda 2 here. So next similarly find for I1. You find for I1. So I1 equal to, so beta 1 1 into lambda 1 plus beta 1 2 into lambda 2. So already we know that from the equation I2, similarly for I2, already we find out, similarly we can find it for I1 also. So from this equation B11 equal to L22 divided by L11 L22 minus L12 square. Similarly, for beta 22 equal to L11 divided by L11 L22 minus L12 square. 2 square. Here L1 is your self inductance of this coil 1 with respect to stator. L2 is nothing but self inductance of the coil with respect to rotor here. L1 is nothing but mutual inductance between the coil 1 and coil 2. Similarly, for beta 2 equal to here beta 2 1 equal to beta 1 2 minus L12 by L11 L22 minus L12 square. L12 square. So therefore, using this equation here, using this equation we get for WF of there are two independent variable lambda 1 lambda 2 interval of 0 to lambda 1 I1 d lambda 1 0 to lambda 2 into I2 d lambda 2. We are going to substitute one I1 we know the answer I1 equal to, we know that, and also I2 also we know that. Substitute we get the answer equal to 1 by 2 into beta 1 1 into lambda 1 square plus beta 1 to lambda 1 lambda 2 plus 1 by 2 into beta 2 into lambda square. So here there are two independent variables. One is for lambda 1, one is for lambda 2, theta 2 here. Suppose we consider I1 and I2 gamma theta is another variable. For that case also we are going to find out torque. We are going to find out the torque. That formula is here. Torque equal to in terms of co-energy, it is for tau W dash into I1 comma I2 comma theta by dou theta. Dou theta. So therefore co-energy is given by, so we know formula here. WF general formula, co-energy equal to, so 0 to I into lambda into d I1. So here variable parameter for I1 I2. That's why reason for I1 here I1 there plus 0 to I2 lambda 2 into d I2 there. D I2 there. So we know that lambda value here. We know that lambda 2 there. Substitute one, we get the answer here. We get the answer here. So here lambda 1 equal to, we know that lambda 1 equal to cell inductance of the coil 1. So L11 into I1 plus L12 into I2. Similarly for lambda 2 equal to L12 into I1, L22 into I2 there. L22 into I2 there. So substitute one, get the answer equal to, so we get a co-energy equal to integral of 0 to I1 L11 into I1 plus L12 into I2 into dI1 plus 0 to I2 L12 into I1 plus L22 into I2 there into dI2 there into dI2 there dI2 there. Here solve this one, get answer equal to, so solve this, get answer equal to simply this one for with respect to L11 and I1 and dI1 plus L1 to I2 into dI1. Similar for L1 to into I1 into dI2 and L2 to I2 into dI2 1. See, integrate this one, we get the answer equal to L11 into I1 square by 2. Here I1 there. So integrate this one, we get the answer equal I1 square by 2. So that can be for L22 into I2 square by 2. So there are two terms here. One is for L12 into I2 into I1 here. So into this one, L12 into I1 into I2 there. This also for L12 into I1 into I2 there. So solve this one, get the answer equal to 1 by 2 into L11 I1 square plus L12 I1 I2 plus 1 by 2 into L22 I2 square into I2 square. So we need for force. We need for force here. So force equal to formula equal to dou W dash divided by dou theta I1 comma I2 comma and theta here. So here I2 was a constant. It's nothing but stator current and rotor current So we know that this parameter we know already find out. This is a co-energy already find out. That parameter we're going to substitute. We're going to substitute here. Variable parameter let's put a theta 1. Yeah. So we are going to differentiate one. We get the answer equal to 1 by 2 is a constant 1. I1 also constant 1. So flux linkage will be variable 1. So that's the reason only for dou L1 divided by dou theta. Here I1 I2 into dou L1 divided by dou theta. Here 1 by 2 into I2 square. Here dou L2 divided by dou theta. So here, so we can form like we can solve one problem here with respect to multiple exit system or with respect to double exit system here. So see the problem here that easily understand. Here we can two coil here. With respect to self inductance, with respect to mutual inductance, that came inductance for L11 equal to 2 plus 1 by 2x, L22 equal to 1 plus 1 by 2x, L12 equal to L21 equal to 1 divided by 2x. So the displacement equal x is given. In first coil, excited current for 20 amps and second coil excited current for minus 10 amps. So in problem asked the question is find the mechanical work done. Suppose if the displacement changes from 0.5 to 1 meter, and also how much amount of energy input given to the each input sources, and also how much amount of energy will be stored. Okay, and also after find out the how much amount of input energy is given and how much amount of energy will be stored. So after that, how to verify the answer? Okay, so by using this one, yeah, input energy supply the source always equal to the increase the field energy and plus mechanical work done. So we are going to add the field energy and work done. So either we get the answer getting or not to easily check it. What's the formula used here? So in terms of co-energy, formula equal to W dash into I1 I2 x equal to 1 by 2 to 1 by 2 into L11 I1 square plus 1 by 2 into L22 I2 square, L12 into I1 into I2 there, I1 into I2 there. So we know the value for L11, 2 plus 1 by 2x, and as I1 equal to 20 square, L1 equal to 1 plus 2x, I1 equal to 20, I2 equal to minus 10 amps, and also L22 equal to 1 plus 1 divided by 2x, I2 equal to minus 10 square. So here, solve this one, get the answer equal to how the multiply this one. So here 2 plus 1 by 2x there, 2 plus 1 by 2x there. So 20 square equal to 400. 400. So multiply this one, 2 by 2 equal to 1, and also here plus 1 divided by 2x into 400. Here 1 by 2x into 20. 20 into minus 10 equal to minus 200, and also minus 10 square equal to plus 101. So solve this equal to 400 plus this all this one is equal to 100 plus 100 by x minus 100 by x plus 50 plus 20 divided by x. So this two parameter will be cancelled. So we get the answer equal to 450 plus 20 divided by x divided by x. So and also you find the work done. Work done of force into distance. Work done of force into distance. Okay. Force into distance. So according to that, we find the formula here. What the formula here? So we know field energy. What is the relationship between the field energy and the co-energy? Formula equal to BF FF equal to dou W F dash divided by dou x. W F dash equal to 450 plus 20 divided by x. Here integral parameter for respect to x. Here dou by dou x of 450. That value equal to 0, and also dou by dou x of 20 divided by x. By x. So 1 by x different this one, we get chance equal to minus 1 divided by x square, the equal to minus 20 divided by x square. So we know the change in displacement equal to 0.5 to 1, 0.4 into n. So work done now, force into distance, force into work done. Here change the work done, So that can be for del W equal to, so changes from 0.5 to 1 into ff into dx. So ff equal to minus 20 divided by x square into dx1. Here minus 1 by x square. Here 1 minus 1 by x square. Into this one minus x per minus 1. That can be witnessed for minus n into minus x power minus 2 my plus 1 divided by minus 2 plus 1 there. That can be witnessed for minus 1 by x, minus 1 by x. So minus 1 by x square integrate பண்ணா minus 1 by x, limit equal to 0.5 to 1, 0.5 to 1, substitute 1 equal to minus 25, here minus 1 by 1, minus 1, plus a little minus there, here also minus there, so minus plus there, so 1 divided by 0.5, so we get the answer equal to minus 25 joules, 25 joules, by joules here. This is for Woodland. This is for Woodland here. So next we are going to find out the how much amount of input energy is given to the each LTK source. So with respect to
multiple edge system. That parameter we're going to find out. We're going to find out. So formula equal to, so in terms of LT energy, formula equal to general formula power, general formula equal to double d change in LT energy equal to integral of I1 into d lambda 1, I1 into d lambda 1. Change the parameter is equal to x 0.5 to 1. So here, therefore, into this one, I1 into lambda 1 with respect to x equal to 1, and placing the coil with respect to x equal to 0.5. We know that lambda 1 equal to formula for plex linkage of the coil with respect to stator. So L11 into I1 plus L12 into I2 there. So we know that L11 value here 2 plus 1 by 2x, I1 equal to 20 there. L12 equal to 1 by 2x, I2 equal to minus 10 there. So we get the answer here 40 plus 50 divided by x. Divided by 50 by x. So we know the value for x equal to limit equal to 1 and 0.5. Substitute 1, we get the answer equal to, so we get the answer equal to 20 into 20 is a I1 current. Yeah. So 20 into here 40 plus 5 divided by 1 minus 40 minus 5 divided by 0.5. So input energy is given of LTO source 1 minus 100 joule with respect to source 2. Source 2. So I2 into lambda 2 into x equal to 1 minus lambda 2 into x equal to 0.5. We know the form of lambda 2 equal to L12 into I1 plus L22 into I2 there. So L12 is value is there. So L22 is value is there. I1 is the 20 amps. I2 is the minus 10 amps. And also x equal to 0.5 to 1. 0.25 to 1. So we get the answer equal to for input energy for source 2, we got minus 10 plus 5 by x. So we are going to substitute one, we get the answer equal to, so changing the LT energy source with respect to source 2, source 2, so we get the answer equal to 50 joule. That is to 50 joule. So there are two parameters we are going to find out. There are two parameters find out. So person is for what's the work done and also how much amount of input energy is given to the coil 1 and coil 2. Okay. So we got this one. Here also we're going to find out minus 100, minus 100. Here also equal to plus 50 joule. So we get the answer equal to minus 100 plus 50 joule equal to minus 50 joule there. Minus 50 joule here. Minus 50 joule there. Here, so we have formula equal to for multiply system. Beta 11 equal to L22 divided by L11, L22 minus L12 square. Similarly, for beta 2 equal to L11 divided by L11, L22 minus L12 square. Beta 1 equal to beta 21 minus L12 divided by L11, L22 minus L12 square. So we know the value for L11 and also L22 and also L12 square. Substitute one, we get the answer equal to, so final solution here 2 plus 1 by 2x plus 1 by x. Here 2 into 2, 1 by 2 into 1 by 4x, and also multiply this one here 2 into 1 by 2x equal to 2 divided by 1 by x plus 1 by 2, 1 by 2x into 1 by 2x equal to 1 by 4x, and also 1 by 2x into 1, 1 by 2x. So solve this one. So take the LCM, we get the answer equal to 2 plus 1.5 divided by x. So here we are going to substitute one. We get the answer equal to beta 11 equal to L22 is known. L22 equal to 1 plus 1 divided by 2x. L11, L22 minus L12 is equal to 2x plus 1.5 by x. So solve this one. We get the answer equal to 2x plus 1 divided by 4x plus 3. Similarly, beta 2 equal to 2 plus 1 by 2x. L1 L11, L22 minus L12 square equal to this answer here. So finally we get answer equal to solve this one. We get answer equal to 4x plus 1 by 4x plus 3. Beta 12 equal to L12 is known minus 100 by 2x. That parameter equal to already we find out 2x plus 1.5 by x. So solve this one here minus 1 by 2x. Here 2x plus 1 by 2 by x term bring this one, x will be cancelled. So finally we get an equal to 1 by 4x plus 3. We are going to substitute x equal 0.5, x equal 0.5 in this equation, and also we get the answer for beta 11 equal to 2 by 5. So we are going to substitute x equal 0.5 for in this equation, we get the answer equal to 3 divided by 5. At the same time, we are going to substitute for x 0.5 for in this equation, we get the answer for minus 1 divided by 5 there. 1 divided by 5 there. So similarly, substitute by x equal to 1, and for above equation, we get the answer equal to beta 11 equal to 3 by 7. beta 2 equal to 5 by 7, beta 1 equal to minus 1 by 7. Okay. So we know the lambda equal to, there are two conditions with respect to 0.5 with respect to 1 there. Okay. So we're going to substitute lambda 1, substitute x is 0.5 in plexing of coil 1. So we get the answer 51. So plexing of coil with respect to lambda 2, that value equal to 0. With this, when you're going to substitute x equal to 1, x equal to 1 for equals plexing of the coil 1 and coil 2. So we get the answer minus 5 and 0 there. So therefore, field energy equal to, ready for field energy equal to 1 by 2 into beta 1 1 into lambda 1 square. So beta 1 2 into lambda 1 lambda 2, 1 by 2 into beta 2 2 into lambda square. So here first condition x equal to 0.5 equal to 0.5. So already find out beta 1 equal to 2 by 5, lambda 1 equal to 50 square, beta 1 2 equal to minus 1 by 5, lambda 1 equal to 50, already find out, lambda 2 equal to 0. Similarly, for beta 2 equal to 3 by 5, lambda equal to 0. So therefore, we get answer equal to, so so similarly we find out for x equal 1 there, x equal 1 there. So beta 1 value is known, beta 2 value is known, beta 2 is value is known, x value only different. So we get answer equal to 475 joules, 25 joules. Therefore, joule. So joule. Therefore, we get the answer equal to, so change the field energy equal to, when you are going to substitute x equal to 1, we get the field energy equal to 475. When you substitute x is 0.5, so we get the answer equal to 500. We get the answer equal to, for in this one, we get the answer equal to all this one. So we get the answer equal to 500. We get the answer equal to 500. So finally, we get the answer equal to 475 minus 500. So we get the answer minus 25 joules. So already we find that there are two parameters we are going to find out. One is for work done, that value equal to minus 25 joules, and also changing the field energy equal to minus 25 joules there. Joules there. So how to verify the answer? Okay, just to verify the answer one. So we know the value for work done. Okay, we know the value for work done, and now we know the value for field energy. So totally we add this one, we get the LTK energy. We get the LTK energy. Here minus 25 joules. Here also minus 25 joules. So minus 25 plus minus 25 equal to minus 50 joules. Minus 50 joules. So already we find out the how much amount of input energy is given to LTK source 1 and LTK source 2. So we get the answer here. That dual equal to minus 50 joule. So answer is verified. Answer is correct. Answer is from the correct. It's from the correct.